Okay, we saw in our last section how to plot a point or an ordered pair, right? Well, in this section, we're going to talk about that ordered pair being a solution to the equation. It's important to see that an ordered pair can be thought of as a solution to an equation with two variables, an x and a y. For example, the point 3, 4 is a solution to the equation 2x plus y equals 10. If we plug in a 3 for x and we plug in a 4 for y, it should make that equation true. Let's check this out. So if I take the equation, I substitute in a 3 for x, that was my x coordinate, and a 4 for y, my y coordinate, the left side should equal the right side. Let's see. 3 times 2 is 6. 6 plus 4 is 10. I know that 10 equals 10. So that means 3, 4 is a solution to that equation 2x plus y equals 10. So if we're given an equation and an ordered pair, we should be able to determine if that ordered pair is a solution by simply plugging in our x-coordinate and plugging in our y-coordinate and seeing if it makes the equation true. Let's try a few. If you look at example number 1a, it looks like I have the point 2, negative 2. And we want to determine if that ordered pair is a solution to the equation 4x minus y equals 10. Let's substitute in our x-coordinate, our 2, and let's substitute in our y-coordinate, our negative 2, and let's see if it's true. Taking my equation, plugging in 2 for x and negative 2 for y, I ended up with an equation that looks like this. Let's see if that left side equals our right side. I have 4 times 2, which is 8. I have the opposite of negative 2. Those two negatives make a positive 2. I ended up getting 8 plus 2, which is 10, and 10 does equal 10. So this actually is a solution to the equation. Now, equations could have multiple solutions. We'll talk about this in a second, but what we really do have in this equation is an equation of a line. And as you know, there's lots of different points on a line. So I could have lots of different ordered pairs that might work in the equation. So just because the first one is, doesn't mean that the other two aren't going to be. But let's check them. Let's plug in our x-coordinate, let's plug in our y-coordinate, and let's see if those work in the equation. Why don't you try it? Pause your video, plug in the x-coordinate and y-coordinate for B and C, and see if either one of those work. All right, for B, when I plugged in 2 and 3, 2 for x, 3 for y, and I simplified, I ended up getting 8 minus 3, which was 5, and 5 does not equal 10. So the point 2, 3 is not a solution to that equation. That point is not on the line. What about negative 2, 2? Is that a solution to the equation? Well, if I plugged in negative 2 for x and a 2 for y, I ended up with negative 8 minus 2, which is negative 10. Now, they look close, but they're not the same. Negative 10 and positive 10 are total opposites, right? Since they're not equal, then that means this is also not a solution to the equation. It's not a point on the line. There might be other points on the line, just not that one. All right, so what that means is if I plug in my x-coordinate and I plug in my y-coordinate, I should be able to figure out what the solution is. Well, what happens if my solution is missing one of the variables? Maybe I know x, but I want to find y. Or maybe I know y and I want to find x. Well, I should be able to plug in one of the variables and figure out what the other variable is. Let's do a few of those examples. If you look at example number 2, it says complete the ordered pair, the point, the solution for the equation 3x plus y equals 12. So I have an equation and I have one of the variables. I want to figure out what the other variable is. If you look at A, it looks like I have the point 1, and we want to figure out what that missing piece is. Well, this is really saying that the x-coordinate is 1 and we want to figure out what the y-coordinate is. We should be able to take the equation, we should be able to substitute in a 1 for x, and then solve it and figure out what y equals. Then I would have the full, complete ordered pair that works in that equation. If I substitute in a 1 for x, I ended up with an equation that says 3 plus y equals 12. I can solve this equation by subtracting 3 to both sides, and I ended up getting y equals 9. That means the point 1, 9 is a solution to that equation. But what if I'm missing the x-coordinate? So if you look at B, it says blank, 0. In this ordered pair, that means the y value is 0, and we want to figure out what x is this time. Let's use the same process. Let's substitute in 0 for y and figure out what my x-coordinate is when y is 0. 3x plus 0 is just 3x. 3x equals 12. I can solve that by dividing both sides by 3, and I ended up getting x equals 4. So that means the point 4, comma 0 is a solution to that equation also. Now I have 2 points that are on that same line. Why don't you try C and D? Pause your video and find the missing coordinate of those ordered pairs. For C, you should have substituted in a -1 for y. We could add 1 to both sides. We could divide by 3, and you should have ended up with the ordered pair 13 over 3, comma, -1. And it's okay to have a fraction. It might be a little harder to graph because you might have to estimate a third of the way through or 2/3 of the way through, but you can still have a fraction for an answer. All right, what about D? D looks like I have a x coordinate of 6, and we want to find the y coordinate. So I can substitute in a 6 for x. I ended up with the equation 18 plus y equals 12. I can subtract 18 from both sides, and I ended up getting y equals 6, which means I have an ordered pair, 6, comma, -6, that's also a solution to that equation. Hopefully you got the same numbers I did. So if we have an equation and one of the coordinates, we should always be able to find the other coordinate if it's missing. Or if we have a full complete ordered pair, an x and a y coordinate, we can always double check that that's a solution to the equation or a point on that line.